So part E, if you picked a random sample of 220 products and found 8% of them to be defective, would that be an unusually high percentage of defectives? So to determine if a value of a random variable is unusually high, you need to compute the probability of getting that value or higher. And then we need to see if that probability is less than or equal to 0.05. So something's unusual if its probability is less than or equal to 0.05. And in this case, we want to know if we have an unusually high number. So we're going to compute the probability of getting that value or higher. So on the TI-84, we would get the following. Again, make sure to keep the division in the last entry to decrease the rounding error. So we want to compute the probability of getting a p-hat that is greater than or equal to 0.08, because we've been asked if 8% is unusually high. So we just check the conditions that we know that p-hat has a normal distribution. And so we're going to use normal CDF from 0.08 out to infinity. Again, the proportions themselves can only range from 0 to 1, but again, this mathematical model that we use to approximate these probabilities with, okay, that axis for the model runs from negative infinity, which we use negative 10 up arrow 99, to positive infinity, that we use 10 up arrow 99. So in this case, our tail starts at 0.08 and runs out to infinity, so 10 to the 99. And then we're going to place in there our mean, which we just computed was 0.05, and the standard deviation, we are going to keep this radical in division in here so that we don't have any round off error building up. So 0.05, 1 minus 0.05 over 220, and all of that under a radical. Alright, so if we were to enter that onto the calculator, our output here would be 0.02059,208. So again, you should pause the video here and grab your calculator and make sure that when you go into normal CDF and type these 4 inputs that you get this on your output screen. So again, just a reminder that that is this shaded area region on the graph. So the area of that shaded region is about 0.02059. Alright, so now if we interpret what we found here, that tells us that there is about a 2.06% chance of getting a sample of 220 products where at least 8% of them are defective. Okay, so we are just putting in words our probability statement here combined with the percentage that we got for an answer here at the end. So that p-hat, remember, is the proportion of defectives in those 220 that we tested, and we were testing to see if that was at least 8%. Okay. Alright, well, that is, so this percentage, so this probability is less than or equal to 5%. So that tells us that 8% is an unusually high value of p-hat if the population proportion really is 5%. Okay, so if the company's telling the truth about their product and only 5% of all their products are defective, we went down and randomly selected 220 products and found 8% of them to be defective. Okay, the question is that possible? The answer to that is yes. It happens about 2.06% of the time. But if we're asked, is that likely to happen, the answer to that is no. Okay, this is less than 5%, and so it would be unusual to see something that far. Okay, so this may be evidence that the percentage of defectives is now higher than what the company thought. And we're saying higher here because we found an unusually high value of the random variable. And so we would reject their claim that the percentage of defectives is only 5%, and we would conclude that the percentage of defectives in the population is higher. So keep in mind that the population percentage might actually still be 5%, and we just happen to get a sample way out in the right tail where the percentage was unusually high. Okay, it could happen. It's just not very likely because the probability is so small. All right, so part F says if you picked a random sample of 220 products, what is the probability that between 4 and 6% of them are defective? So in this case, we're looking for the probability of getting a p-hat between 4% and 6%. Okay, or we can write that as 0.04 and 0.06. Okay, so on the TI-84, we would compute that by taking normal CDF. This one we actually have two finite endpoints, so we would enter the left endpoint is 0.04, the right endpoint is 0.06. Curve is centered at 0.05, and the standard deviation 0.05 times 1 minus 0.05 divided by 220, and all of that under a radical. So again, you should pause the video and you should grab your calculator and go into normal CDF and input these values and make sure that you can get the result of 0.5038481 So on our distribution curve of p-hats, again, down here on the horizontal axis, we now have a p-hat axis, and we've shaded between 0.04 and 0.06. So again, that shaded area there is about 0.5038. So again, if we interpret this in the context of the problem, there is about a 50.4% chance of getting a sample of 220 products where between 4% and 6% are defective. Again, we're taking these from a population where 5% of all the products are defective.